It's working. I mean, it's just a slideshow, so I don't. It's not like super technically complicated or anything. Um, shall we start? Cool. I hope I can. I hope I'm loud enough for my own. So I'm recording this so I can show it on YouTube. I don't know why I'm not like some sort of YouTube person, but I think it's just nice to have a record. Sorry.
Do it.
Yeah, all right. Cool. So my name is Sean. I go by Swix on the internet. This is a book report. It's kind of like elementary school, middle school. Like, hey, I read this book. It's a great book. Orda has a copy right there if you're interested in browsing it, checking it out. And I'm just sharing what I learned about it. I had probably sold like 100 copies based on my telling people about it, but I don't even know the author at all. I just think it's one of the better introductions out there. So I also named, this is the formal title of this talk, Programming TypeScript, Cultural Learnings of Programming for Make, Benefit, Glorious Users of TypeScript, which all of you are. And this is not a book ad. I'm not trying to get anyone to buy the book because I don't have any affiliation. It's also not a summary. I'm just like adding comments and stuff. I just think that learning by reading technical books cover to cover is insanely underrated in our industry. People put years of effort into writing these things and then we never read them. And say we look at Twitter and blog posts. I think that's shortchanging yourself in terms of technical depth. And I just want to give you an idea of the kind of things you can learn by reading these things in depth. So I'm Sean. I work at Netlify as a developer experience engineer. We don't use TypeScript at Netlify. Trying to change that. I'm also a moderator of the r/React.js subreddit. There's 130,000 of us talking about React, sharing our projects and hiring each other. So join us. I also maintain the React and TypeScript cheat sheets, which you may have seen. Which help you from basic to advanced to migrating from JS and Flow to higher order components and maybe teach you some Chinese. I also made stickers. So these stickers are something I made with my own money. So basically the whole deal is you have to contribute or have contributed to the community and just tell me and I'll just give one to you. But I try not to give them out freely because you gotta earn it. And so basically the story of this whole thing started when I got this book as a gift from another friend who was reviewing the book. And then I had a long plane flight, so I just read the whole thing in the 14-hour flight. And then I just folded the edges of every page where I learned something. And so that's a nice data viz of what I learned. And this is the talk version. I'm not presenting all of it. But this is like the whole table of contents. We're never going to cover all of that. I do strongly think that if you corner me, I'll probably have something to share that's pretty exciting. But our plan is just a very simple subset of that. We're just going to talk about like a basic sort of type introduction for people. Basic types, functions, and advanced types. All right. That doesn't mean anything. So I really like the way that he introduced TypeScript. I think the way that we talk about TypeScript is super important, especially when we try to talk. Like I have a policy of never try to convince anyone to convert to TypeScript. But I think that a lot of people who already have rejected TypeScript in their minds don't have very good framing of what types can bring to their projects, especially if they think that their testing is sufficient. So I really like the way that he introduced it, saying basically that using types to prevent programs from doing invalid things. And based on that, I actually wrote a CSS tricks article, basically making a case for having both types and tests in your project and where they overlap. And basically the sort of TLDR of it is that tests are best at ensuring that happy paths in your program work. But you're never going to write the infinite tests that unhappy paths do not work, right? No one writes tests for that. So you want to use types to prevent unhappy paths from even existing. And that's even without the benefit of static analysis, which moves the discovery of errors from runtime to write time. So that's the first I think that's something I got from reading the book, that how we talk about TypeScript is equally as important as diving deep into the language features itself. So now it's the second piece, which is he titled it All About Types. I try to call this like kind of like object trivia. So the other Sean introduced you to some of the basic types that are available in TypeScript. There are some interesting choices, so we're going to dive in a little bit. So here I have a whole bunch of assignments, right? And they're assigned to any type, and these are all legal because any accepts everything. Let's talk about the object type, capital O. So I have examples 1 through 9. Which of these are invalid? So foo is a type capital O object, and it's assigned to all of these things. Which of these are invalid? Two? Order says 2. Yeah.
7.
2, 7.
9.
2, 7, 9. Anyone else?
8.
2, 7, 9, 8. 2, 7, 9, 8. Okay. Anyone else?
Strict or not? Because 8 and 9 depend on whether you're strict compiling.
Interesting. I think I was strict for this one. So we got 2, 7, 8, 9. The answer is actually 8 and 9. 7 and 2 are allowed under the object type. I have no judgment on this. I just like, this is a little bit like trivia, but then also it matters what you type things sometimes internally. And basically you have to be aware of what it accepts, because the problem with TypeScript is that it's modeling the very, very dynamic nature of JavaScript. Like people try to blame TypeScript for it, but no, blame the underlying language.
No, blame yourself.
Yeah. Don't actually use the object typed capital O, but it's there if you want it. But guess what? We don't have just capital O objects. How about small o objects? All right, same game. 1, 2, 3, 4 until 9. Which is invalid? Let's go with that. Small o object. So remember last time 8 and 9 were invalid. So what else? What becomes valid now, and what becomes invalid?
Just 9.
Just 9 is invalid. So null is a small o object. That's wrong. Everything from 5, 6, 7, 8, and 9. I don't know. I kind of justify it on like a prototype basis, I think. And these are all like literals, right? If you can see it that way. But look, you're never going to remember this. Just know that there's a difference between big O and small o. If it ever comes up, you'll remember this moment in your life. We're not done. Ready for the final boss? Parentheses, curly braces. This is the third type of objects. Yeah.
Only one.
Only what? Number 1? That's invalid.
That's valid.
That is valid. 2 to 9 is invalid. That's wrong again. In fact, our open close curly brace is an exact synonym of capital O object. Why? But this is the kind of thing, like, I don't know, like, you'll never, 99% of the time you never know, and then the 1% that you need it, you're going to be glad to know that there are 3 types of objects in TypeScript. Interfaces for the types, I want to just like give a shout out. There is such a table if you ever run into the issue of like arguing on your team when to use which. Interfaces best for public APIs, types best for like union types and stuff like that. This is done by the Rollclaw TypeScript meetup. They're massive. They're like 200 people, very, very engaged. I'm good buddies with one of them. And I strongly recommend checking this out. I have this on my React TypeScript cheat sheet if you need to look it up for work. That's the first thing I learned on the basic type chart. The second thing I learned is that union operator merges. It is not an or. So I have I have an object type one name here. It's got a property of name. I have another object type first last. It's got first name last name. And I have a person, which is either one name union first last. You'd be tempted to read this as one name or first last. It is not or. Why? Because I can assign a type of me, like person, right? And I can give it a property of name and a last name and no first name. That's what the merging is. It merges these 3 things into one thing of person. And it tells you about that. And so that's a really freaky concept to kind of get around the first time you sort of encounter it. And that causes weird things like this, where like I want to check like, all right, if this thing has a dot name, if this thing doesn't have a dot name, then I can safely assume that has a first name and a last name, right? Because I can assume it's a first last type. But TypeScript doesn't like that. It just says search.name, property name does not exist in type first last. And this insight that the union operator merges instead of is an or is actually key to understanding why you have discriminated unions. Yeah.
Well, I would like to point out that this would work if instead of last name in that assignment you used any other property name.
Yeah.
Because that value is assignable to one name. It's not that it's compatible with both.
Which one?
So the object with the name property and any additional properties is assignable to the one name type. So that's why it's assignable to the person type. So if you change
yes.
it to something else, it'll still work.
Yeah. Gotcha. Honestly, there is a better example in the book. This is one I came up for this slide because I already passed the book on to someone else. But there is one in there that I highly recommend checking out. I understand. I now understand because like this is something I don't know. It's coming up with examples to demonstrate type exhaustiveness is not easy. But okay, so I'll fully grant that may not be the best example, but just understand that union operators do merge object types, and so that's why you want discriminated unions. Particularly, a lot of people illustrate discriminated unions with a property name of like kind or type. I want to tell people that that's not a special name in any case in TypeScript, so I call it potato. But basically, just like anything with a literal, TypeScript can actually discriminate on, and then here the inference will be done correctly. It will be narrowed correctly to the correct type. And so if you ever have weird stuff like this where like you already filtered it and in normal JavaScript it would work, this is the kind of thing that you might have to do in TypeScript. We'll present some other strategies as well, but I think understanding the why of discriminated unions will help you remember discriminated unions. Yeah? Okay, so, and then also Reed Bassarat, this is one of the original gods of, of community TypeScript, where he also talks about some tricks to use, this guards against your coworkers adding extra types. And uses TypeScript to raise an error if any extra types are ever added to the union type of shape. So that's pretty cool. I like that a lot. Excess property checking. That's something as well that is a really nice feature in TypeScript, which confuses people sometimes, and then you kind of take it for granted. You don't know it's a special name of it. I think knowing names is very powerful, so that you can talk about it with other TypeScript users as well as report bugs. Or just like describe your own problems so people can help you, right? Help people help you. So what excess property checking is I've got two defined properties, both are optional, color and width, and then I've misspelled color here, but both of them are optional, so I could technically pass it in. It's just that in TypeScript we actually choose to error on this and warn you about it, and even give you like, did you mean corrections. Like, did you mean to write color with the correct way instead of the British way? So that's what is excess property checking. In JavaScript, this is totally legal. In TypeScript, we've just chosen to make this an issue. There are ways to get around it. So bailing out of excess property checking is a very, very good chapter within the book. So one strategy is to assign like explicitly say I'll accept any other string, and therefore any excess properties will be explicitly accepted within that type. This makes a lot of sense. Now, for things that make less sense, you can also assign your object to another object, to a variable that let them infer the type, and then pass it in, and that bypasses the excess property checking directly. This is not something you should do, but if you do end up accidentally doing it, it may throw you, because you might think that excess property checking would catch you if you make this kind of error. It does not. And yeah.
Does the book mention that that's a bug?
It's not a bug.
Okay, cool. Just checking.
Yeah, it's you know where I got this? I got this in the TypeScript docs.
Hey.
So I don't actually have the book with me anymore. I passed it on. So all these examples I created today. So there are like sort of very well thought through and annotated examples, and you want to know that. You want to be able to run the compiler in your head. Maybe not, but like when you run into trouble, you want to do that, right? Like, you know.
Why doesn't this work again?
Because the inference infers like that this type is correct, and therefore this bails out of the access property checking down in here.
So there will be like a runtime tag, or it's just
No, it just won't. Sorry.
It will be just null for you. I mean, for yeah, color is optional. Yeah.
Yeah, everything's optional in there. Yeah.
Is it not because if you pass a literal object as an argument to a function, then any excess properties are not going to be used anyway, so you can make assumptions about it being wrong. Whereas if it's captured in a variable, you might use it elsewhere.
I'm creating it right there, man. I don't know. All I'm doing is I'm assigning it in between.
Using it elsewhere.
Yeah.
You're creating it right there.
Look, I don't make the rules. I'm just saying. I read the freaking book and I was like, oh, this is a thing.
Interesting.
I'll tell you even more. You can bail out of bailing out of excess property checking. I was too lazy to come up with an example. Just read the damn book if you need it. This particular TypeScript feature is a rabbit hole. All right. So basic types recaps. Object is triple equals curly braces object, but object big O is not equal to small o. Union operator merges. That's why distributed unions, as well as excess property checking and how to bail. So that's one chapter of the book, right? Like that's what I got. There's other stuff, but like that's me as like a moderately experienced TypeScript user. I got that just by reading the book. I think you pick up on things that you thought you knew, and then you just kind of read through and look for the diffs between you and the book. Another one I found was functions, chapter 4. Overloading function types. This is the canonical example of how to overload. Again, pulled straight from the TypeScript docs. Basically, you just have function signatures, but with no implementation. And you go like 1 argument, 2 argument, 4 arguments, and then you implement all of them in a way that accepts all of the previous signatures. That's function overloading. And that can be a bit tricky for first-timers, but you get used to it. And therefore, that raises errors if you only pass in 3 arguments where we don't have any overloads. Yeah, everyone with me? So the question then becomes, how do you overload arrow function types? I actually have personally struggled with this because I like using arrow functions. Who does it? You can't do that. You can't do this with like a whole bunch of consts. Yeah, it just seems like an intractable thing until you read the book and you realize that functions are callable objects.
Yeah.
So here's a nice thing to just show you that the sort of arrow syntax is a shorthand function where you just use this arrow, and then the longhand function is an object, right? That happens to have a property that's a parenthesis for like callable, and then it has a return type. So functions are callable objects. Just always remember this. Why is this important? Because when you want to overload, you can declare something like this, a type of whatever, and then you declare multiple versions, multiple overloads of that function. And then you can just assign that to your variable that stores that arrow function. And so this is the way to type arrow functions. To overload arrow functions. I feel like that's not super common knowledge because I looked around and I didn't. Yeah, I mean, I think people who have been with TypeScript for a while will know this, but anyway, I only learned TypeScript like a year ago. So functions are callable objects. Second part of the functions part is where are generics bound? When you first learn about generics, you think you know where generics are bound. First of all, you can bind them on the left-hand side of the equal sign, and then the other time you can bind them on the right-hand side of the equal sign. So here I have this binding on the right-hand side, and so you can assign without actually specifying the generic, for example. On the left-hand side, you start insisting on the generic being defined up front, and that's why you get an error here because it requires a type argument. So if you see these errors in your code base, you know where it's coming from, right-hand side, left-hand side. The fun fact is that these are not the only way to bind generics. There are actually 5. And they're all just translations of this syntax for shorthand and longhand functions. And as long as you remember that their functions are callable objects, you'll take care of 1 and 2. And then 3 and 4 and 5 are relatively straightforward with the left-hand side and the right-hand side syntaxes. They're where you might imagine they might be if you're at all familiar with generics. Again, this is not for the beginners in the room, but just remember that there's always a little bit more depth. Variadic functions, cool way to just say it accepts multiple arguments. This used to be, I don't take this for granted at all, this used to be the way that you just accept types. Except that the inferred type is any. And I think there was a lot of work going on in the TypeScript. I don't know what had needed to happen, but this took 3 years to implement variadic types where you could just spread the types from a type array. So this works as you might expect now, but this was a big deal when it launched. So that's the functions recap. 1, functions are callable objects. 2, there are 5 ways to bind generics. 3, variadic functions just work. And then finally come to advanced types. This is, I've already have gone too much time. Here's the problem statement. There's something embedded deep in, there's a type that you really want embedded deep inside an object. You only want that. But they never exported it for you to use. This is for like a third-party library. They never exported it for you to use, so you have to just like rewrite the whole thing. Nah, you can just use the key in operator. This is not an official name, but you can just say, you can just use square brackets and then pass in a string literal as the key in operator.
They're called index.
Yes, that's yeah, index access type. Here's an actual use case. I wanted to pass in to write a function that took part of the result, and then I looked deep into the type defs, and I only wanted this view. I didn't want any of that, right? I didn't want to rewrite the whole thing, and this was not exported for me. So in real life, I just use return type of the function of the hook, the React hook, and then I keyed in to that particular field, and I got that type that I needed. That's all I have to do. So this is called index access type. The book calls it key in. Nobody on the TypeScript team agrees with it, even though they reviewed the book. User-defined type guards. This is also a cool feature, another way to distinguish between a union type. Yeah, I don't always spend too much time on this because you can pull this straight from the docs. I think it's really cool. The thing you have to know is that there are a few ways to narrow types, and if you are to use union types at all, you have to know these things. Like not all of them, but like you should have a toolkit of like problem-solving solutions to narrow types, because otherwise you're gonna run into things where like TypeScript is just getting in your way, and it's very, very frustrating for people just picking up TypeScript for the first time, especially if you're trying to guide people into TypeScript. And so user-defined discriminated unions, and then these are slightly easier ones that you can start off with, type of, instance of, and in. Simulating nominal types. A lot of people, I really cringe whenever anyone is asked like, what do you want for the future of TypeScript? And they're like, nominal types. And that's so idiotic because it's so much harder to do structural typing, and that's what we have right now. And you can actually simulate nominal types, basically the same strategy as discriminated unions. I also like this one I think this is from the book as well, type branding, which is a companion object. Basically what the use case of this is, let's say you have 2 IDs of type string, but you don't want them to be assigned to each other, right? This is order ID is of type string. User ID is of type string. You don't want them to be assigned to each other because they're both string, and TypeScript doesn't tell the difference between them. Basically, you create a companion object and you wrap them around each time, and so that they'll make it extremely clear that you cannot. And the function that tries to accept the wrong type will actually error for you. And so that's a simulation of a nominal type that's good enough in a structurally typed language. Distributive types. I really, really like this just because people who explain generics don't do this. What does this mean? Basically, you put in a bunch of union stuff, right? And then you like pass in this generic function, and out comes some result of some process that seems kind of opaque. This is the simplest form of that, but you've seen more complex generic types. So the book actually walks you through step 1, 2, 3, 4, 5. First of all, you look at the inputs. Second of all, you take each of the union types and you spread them like a map operation. So union type dot map, and you map the without, right? And then you substitute each of the withouts with the underlying type. So here I'm substituting with Boolean. So it's Boolean extends Boolean, question mark never colon Boolean, and you do that for each of the union types. So you distribute, you substitute, you evaluate. So Boolean extends Booleans. This evaluates to true, so that becomes never, right? That's a term we inline. Number extends number, evaluates to true. Okay, this is a typo from me. This should evaluate to number. And then string extends strings. Okay, I screwed this example up. But basically, distribute, substitute, evaluate, and then get rid of the nevers, and you simplify, and you get the output of that. And that's how you go from this complex sort of type arguments. Pass it into a type operator that you created yourself, and then you output that. And you can read this in a reasonably sort of logical form. Okay, so recap: key and operator, type narrowing, simulating nominal types, and distributive types. Chapters 7 and 13, I have no way of covering them at all. I will just highlight these two chapters. I thought they were really interesting. I've never seen any treatment of async streams as well as multi-threading in TypeScript. So if you ever need that, this is the book to get. And then also I liked the discussion on migration paths, the sort of 4 steps with 2 options of strictness, as well as ambient declarations. I think those are very, very powerful as well. I'll just give a quick shout out. You should know what script mode versus module mode is in TypeScript. Basically, module mode uses the keywords import and export. Script mode does not. Once you're in script mode, then you can use all the ambient declarations that you want. Basically, they're globals for your entire project. So you can use ambient types, ambient variables, and ambient modules. This, combined with declaration merging that you saw earlier, is the way to fix issues in types that you run into. So really, really just like be strong in those fundamentals, and you'll never run into these issues again. So almost the end. Why actually the book? You can get all this in the types in the docs. I think style points, like making TypeScript interesting, is hard. So he has a lot of style points, like just like yelling and like talking about your neighbor's kids and all that. Like just like injecting some passion into it and making sure that like you're talking to a human at the end of the day. Exercises, going through these exercises, help you work through your understanding of TypeScript and find areas in which you might be misunderstanding some stuff. And that's it. That's the whole. Those are the top highlights I would get from the book. Definitely, the message is not to buy the book. The message is read more books, because you really get to work on your understanding and take your TypeScript skills to the next level. So thank you. Does anyone have questions? I think we have questions in between.
Yeah, got time.
When?
Yeah, was there anything that it didn't cover that you would have been interested in hearing more about?
Okay, so you mean just like the 7 to 13?
Well, no, just like stuff that you would have.
What's missing?
In the book that you didn't hear about.
No. I think there's a lot of exploration of end-to-end types right now. So the thesis being GraphQL is your types backend. It should flow the types down to the front end, so you don't so that breaks in your backend would immediately reflect in your types in the front end. As far as I can tell, only like Airbnb does that, but I think it's something that everyone's extremely interested in. And Microsoft.
No, real life is that.
And really, so Facebook definitely does it. But yeah, I mean, like the idea that if you're bought into types on the front end, you should probably buy into types in your communication between front end and back end. That seems like it makes sense. So yes, that was entirely missing from this book. But I think this is a very good coverage of the language. Everything else is just tooling. Okay, cool. Talk to me after this, and then also ask me about stickers. Cheers. Thank you.